All right, we are going to take a look here at factoring the sum and difference of cubes. Okay. The sum and difference of cubes have specific formulas here. I've got a sum of cubes, that's the a cubed plus b cubed, a plus b, a squared minus ab plus b squared. And then my difference, a cubed minus b cubed, a minus b, a squared plus ab plus b squared. Typically what I remember is, if I'm going to be factoring a sum of cubes, I start with a sum. If I'm going to be factoring a difference of cubes, I start with a difference. Everything else is the same except for this one sign. So in the difference, we got a plus over here. And in the sum, we've got a minus. So basically what I remember is if I'm starting with a plus, opposite sign. If I'm starting with a minus, opposite sign. Okay? Takes some time to get used to the two formulas. One of the things that's definitely beneficial is over here, I listed out all of our perfect cubes. Well, not all, but from 2 to 10. I guess I left off 1. I mean, technically, 1 cube is just 1. So we got that guy too. All right. But I've got all of my perfect cubes here. Some over time I get used to and I recognize a lot faster than others. I mean, I'll tell you right now, I'm pretty good with my perfect cubes through 6. I usually remember 9 and 10, 7 and 8. Sometimes I forget. But you know what? I've got a calculator. I can go type in what 7 cubed is and see 343. Okay? What's telling me that I'm looking at the factoring a sum or difference of cubes is I actually see a variable cube. So if I saw x cubed plus 512, for example, and I'm asked to factor this, you're right, I might not recognize that 512 is a perfect cube right away, but I know it has a very strong possibility of being a perfect cube because the x is cubed. I got two terms. If this is a cube, which I can tell pretty easily, I need to check if that is. If that is, it's going to factor as a sum of cube. If it's not going to factor. So if I went on my calculator and just said, oh, cube root of 512 is 8, or I'm just going through, hey, 8 cubed, hey, that's 512. I've got a sum of cubes here. One of the things that I will do, since I need to kind of fit it into the formula, I will rewrite this guy as x cubed plus 8 cubed. I want to see what's being cubed. It's obvious x is being cubed. I see x cubed. So I want to know everything I've got that's being cubed. This is my a value. 8 is my b value. Right? So a cubed plus b cubed. What's being cubed? X and 8. So if I want a plus b, there it is right there. It is x plus 8. There's that a plus b. A squared, the first one squared, x squared, minus a times b, 8 times x, 8x, plus 8 squared, 64. Notice when I was going through the formula. Yeah, I'm looking back up here, but I wasn't looking back at this guy. I'm looking right here. I already know I'm starting with x plus 8. Here I got x squared minus the product, 8x, plus the square of the second one, 8 squared, 64. So let's say we have x, y, we'll write it like this. I'm going to write it as x cubed, y cubed, minus 64. All right, I can tell the x is cubed, the y is cubed. I can see the power there, so I know that. Okay. Question is 64 perfect cube? Yes, it is. Yeah, I've got it in my list. Maybe it's one I know, but if anything, I know at least to go on a calculator to see if it is, and it is. It's 4 cubed. All right. So I want to rewrite this. This would be xy cubed minus 4 cubed. I want to see what's being cubed. That's what's going to help me with my factoring. I know this is a difference. I know I'm going into this formula, but I need to see what exactly is being cubed. Well, on the first one, it's both the x and the y. On the second one, it's just the 4. Well, Sometimes parentheses can help you. Throw parentheses in there. I need to see the two pieces that are being cubed. It's a difference, so it's going to start xy minus 4. Now I'm looking at my formula, but I'm looking right here. I'm not looking back here. I know what I'm starting with. A squared. Hey, that's x squared y squared. That first term squared. Plus the product, 4xy. Plus the square of the 4, 16. There's my factoring of a sum of cubes and a difference of cubes. I'm first looking at, hey, what's actually being cubed? There they are, x and 8. What's actually being cubed over here? There it is, xy, 4. Once I have that, I know how I'm going to start. Okay. Do a couple more up here. Let's say, this will be number 3. So let's go 27y cubed plus 64. Again, even if I don't recognize right away that 27 and 64 are perfect cubes, I know to at least go check that out because I see y cubed. Okay. I want to write what's being cubed. Okay. So I'm going to write this as 3y cubed. 27 is 3 cubed, so I'm cubing both the 3 and the y. 64 is 4 cubed. Again, also, if it helps you, throw that 4 in parentheses. I just need to see what's being cubed. Here's my two values being cubed, a 3y and a 4. It was a sum, so I start with a sum, 3y plus 4. Square the first one. That's 9y squared. Squaring the 3, squaring the y. Minus the product. 4 times 3y is 12y. Plus the square, 4 squared is 16. There is my factoring that sum of cubes there. Okay. Let's go with this. Let's go 216 z cubed minus 1. Again, get a couple different looks here. In this first part, both the 6 and the z are being cubed. Again, I don't recognize 216. I'll go on a calculator, check it out, but that is 6 cubed. Over here, 1 is 1 cubed. There's my two pieces that are being cubed. I've got a 6z and a 1. It's a minus, so I'll start minus. It's a difference, start with a difference. 6z minus 1. Square the first. 6z squared is 36z squared. Square the 6, square the z. Plus the product. 1 times 6z is 6z. And plus the square of the last one, 1 squared is 1. There's my sum factored out. How about this one? Let's go 5 here. We'll go 8x cubed plus 125y cubed. Okay. So I'm back to a sum of cubes. Again, I need to see what's being cubed. This right here isn't ever necessary. But man, I sure like having it there because it tells me the two pieces that are being cubed. So when I look at this 8, 2 and the x are being cubed. 125 is 5 cubed, so 5 and the y being cubed. Writing it like this does help me. It helps me see the two pieces that I'm going to be working with. I'm going to be working with a 2x and a 5y. Those are my two parts. So here's my start. It's a sum. 2x plus 5y. Square the first one. 4x squared. Minus the product. 2x times 5y, 10xy. Square the last, so plus 25y squared. One of the toughest things I think to get used to is the two different formulas. But what I remember is they're pretty similar when you look at it. I remember, once again, I said this earlier, if I see a plus, I'm starting with a plus. If I see a minus, I'm starting with a minus. And then this inside piece is going to be that opposite sign of what I started with. So if I start with a minus, there's the plus. If I start with a plus, there's the minus. Okay? This is always going to be plus. This is always plus. Always think of it like this. I'm squaring. If I square, I get a positive. So that's plus. That's plus. But I'm looking at this, be that opposite sign. I don't need this. But until I get used to it, it sure does help because it helps me see what's actually being cubed. The 2x and the 5y, the 6z and the 1. It helps me see what I'm working with. So definitely very beneficial. Okay? I know when I look at this now, I might not write this down all the time because I've done this quite a bit. But when I'm looking at 8x, I'm thinking 8x cubed, I'm thinking 2x. When I look at 125y cubed, I think 5y. I'm thinking that. I'm just not necessarily writing that down every time. But this is definitely very beneficial when you're first learning this to write down what's being cubed because it's telling you what to put right here. Whatever's being cubed is going right there in that start. That is that A and B value.